today we have our guest, Mr. Jason Walsh. What are the challenges that TR-369 is trying to address? What is the primary intention?
It's an evolution of another that people may or may not know, which was TR-69. And that was made 20 years ago.
How do you see managed Wi-Fi, USP, and AI-driven data models?
I think the best answer to that question is the value to the operators.
What are the efforts that USP is doing in order to achieve its intention?
Basically all those things. Not to go too down into the weeds, but the thing that makes USP powerful.
What's the adoption of USP with vendors today look like? So is USP already in deployments?
It is.
Welcome to Weekly Wi-Fi Wisdom podcast series, where we talk everything about Wi-Fi and the tech that surrounds it. I'm your host, Sainad. I'm WLAN QA engineer at Candela Technologies. And today we have our guest, Mr. Jason Walsh. And he is from QA Cafe. He has long working history at the Broadband Forum. And now he is currently working as Director of Technical Marketing at QA Cafe. And in today's episode, Jason joined us to have a conversation about managed Wi-Fi and USP, user services platform, and also about the data standardization that the industry is trying to achieve for today's AI use cases. Welcome, Jason. Thank you so much for joining. How are you doing?
I'm good. I'm good. Thanks for having me. It's like you said. Yes, I've been doing broadband for a very long time. I have to wear a lot of hats.
Yeah. I was just going through your LinkedIn profile and I was amazed about your working history and also the kind of posts that you're doing, emphasizing on the importance of the standards for any technology in order to succeed.
Yeah, it is super important, and I think having been doing it as long as we have, like I always joke, my friend and I always joke that almost every technology goes through the exact same process every single time, to the point we could probably write about it, right? When it comes to standards and interop, like it's like first something is new and kind of proprietary, and then everybody demands that it's standardized. But then some people don't want it standardized, and then they fight that, and then it becomes standardized, but people fight the standard, and then eventually you have testing and certification.
Absolutely. So let's discuss all of those things in today's episode. So let's get started. So when we talk about managed Wi-Fi, how has that evolved over the years? And is there a trend today that the operators choosing managed Wi-Fi networks, leaning more towards managed Wi-Fi versus leaving the networks unmanaged? So what's that evolution over the years?
So I talk about this. So I have a podcast as well, called Epic Melon, and it's basically interviewing people like us, right? Like who are, and um, but one of the topics that comes up constantly on the show is the weird situation we're in when it comes to consumer networking. And the reason it's weird is because even internet access itself was consumer first, right? Like when dial-up modems first started, right? Like the operators, the service providers and the telcos were not involved at all, right? You made a phone call and they got some money and they were happy with that. And then we were just connecting to, America Online or Prodigy or bulletin board services, all these things. So it was a consumer first technology. And when Wi-Fi came along, it was the same thing. It was very much consumer first technology, to the point where the entire culture around it and the consumer understanding of it was as if they are going to buy Wi-Fi products, right? They're going to buy their Wi-Fi router, they're going to buy their APs or whatever. They're going to set it themselves, and it's their network and they're responsible for it, right? So over time, we learned that that's not very sustainable because Wi-Fi is very complicated. It doesn't necessarily work for all of the use cases that we want it to. It was not designed for some of the things that we're trying to do with it today at all, right? And that's why you're getting Wi-Fi 7, Wi-Fi 8, right? Because they're trying to solve problems that existed, right? Because originally, Wi-Fi itself was just Ethernet over the air, right? They were like, oh, wait, remember that problem we used to have that we solved with Ethernet about collision domains and shared media? What if we just did that again, right? But then you suffer all the same problems and it ends up not being useful to all use cases. Um, but when the consumer themselves are just trying to handle that, like that just quickly started getting out of control. And over time, because it became so ubiquitous and so basic of an understanding from the consumer perspective, and I say consumer perspective all the time because uh, one thing I always say when we're making standards is like people like you and I and the people in the room making standards, we are not the use case, right? Right? We know how to tweak things and how to set things up correctly. We understand the difference between Wi-Fi and the internet. But 99% of the population, that is not how they view things, right? They view their Wi-Fi connection as the internet. Ergo, when broadband became a thing and the operators started taking responsibility for this connectivity and the branding of it and the entire consumer experience, it was theirs. So that relationship became the consumer and the operator, no matter how good or bad that experience was. And we know that the majority of that experience is affected by the Wi-Fi. So fast forward to 10 years ago, 5 years ago now, the operators now understand that that is the most basic use case of the things that they need to take ownership of. Because if something goes wrong, and this goes for everything too, right? So it's even with smart home things. If something goes wrong, it's the operator's connectivity that gets blamed. And so the very, very top thing that they are all trying to solve is taking ownership of it and doing managed Wi-Fi. Now, that has evolved from, as you know, from all of the stuff that you guys have tested, uh, this has been proprietary for a while, right? There were many different companies that had their own way of solving this problem. Some of it, sort of automatic, some of it actively managed. But that's not sustainable in long term. I mean, we'll eventually go into why standardization has to happen, but that's where we are now. Is that use case is so strong and is worth so much. It's so many headaches and so much money to the operators that it is the top thing that they are trying to solve when it comes to using device management, using management protocols.
Absolutely. When the technology is so complex, we can't leave the issues to the customer. Hey, you fix yourself. No, we cannot say that, right?
No, and it was like I said, it was like that for so long, like but they don't know.
Good to see that operators are accepting that networks has to be managed and take more ownership instead of leaving it to the users themselves. Right. With this context, let's move on to TR-369, the user services platform. So, for those anybody who are new to it, what are the challenges that TR-369 is trying to address? What is the primary intention of the standard?
So it's an evolution of another management protocol that people may or may not know, which was TR-69. And that was made 20 years ago. And that was made to solve the onboarding, mostly the onboarding problem for operators, right? So instead of sending you a CD ROM that you ran on your PC to set up your router, right? They were like, wait, let's do this with an actual WAN side management protocol. And that was TR-69, CPE WAN management protocol. And TR-69 was built to do some very specific things, mostly configuration, mostly uh, not diagnostics necessarily, but like support, firmware updates, things like that. But it's very big and very slow and based on older technologies, things that were around in 2004, right? SOAP and XML and stuff like that. So in 2015, we sort of saw where things were headed and realized that we had to basically rip open the hood of TR-69 and say, okay, what are we going to do next? And that's how USP started, it sort of started as TR-69 2.0. Um, Consequently, while we were doing that, we realized all the things that we now had the ability to do with new technologies that were out there, having always on communication, having much smaller payload sizes, using protocol buffers rather than XML to send things over the wire. And that allowed us not just to make the same use cases as TR-69 better, but also opened the door to all sorts of other things. And so the things that USP is most effective at now are having those real-time communications, having them be lightweight, and being able to scale. So consequently, those are the things that people are using it for first, right? The migration is happening mostly on uh, use case basis, right? So either people are they're migrating to USP on new devices or for new situations, and managed Wi-Fi happens to be the biggest of those, right? And then it's also it's much more well built for telemetry. It's even more well built for telemetry than some other larger core network management protocols like NetConf and SNMP and stuff like that. So
Yeah, I was coming exactly to that point in my next question. So now the intentions of TR-369 are clear. So it built on top of TR-69, but enhancing it much broadly and way better. But how does it exactly do that? So as you mentioned, is it by defining certain metrics in telemetry data, or enforcing any rules in configuration while configuring a device, or enforcing policies to maintain compatibility during any firmware changes, things like that. So what are the efforts that USP is doing in order to achieve its intention?
so yes, it's basically all those things. And um, not to go too down into the weeds, but the thing that makes USP powerful is actually the data model, right? Which people might know as TR-181, um, or the device 2 data model. And that has maintained consistency from TR-69 to USP, so that there could be some backwards compatibility, but also because we started to standardize those things already, right? Like the way that you describe a connected consumer networking device is defined in TR-181. It just really is. And so that's evolved over time in so many ways, right? Because that's been around since 2010. And uh, the things that were added for USP are things that make it a little bit more extensible, right? So a lot of because USP can do all of those things, right? It's built for telemetry, it's built for configuration, it's built for monitoring, it's built for real-time changes, right? Like actively steering things so that something will get better. And then when we talk about AI or whatever later, that's where a lot of this will come down. But the standardization of the data model is really what made all this possible. And when it came to Wi-Fi, um, that has evolved over time as the broadband forum has become more and more involved in it bidirectionally with groups like the Wi-Fi Alliance, right? And so the metrics behind, say, Easy Mesh, which are known as Wi-Fi data elements, right, are we worked very closely with WFA on getting those into TR-181 so that the metrics are all standardized. And when you use USP to either collect that data or configure something, right, or run a command like uh, scanning for other networks and things like that, neighbor scans, and that's all things that you can do through the data model that is things that were defined by the WFA that are now in the TR-181 data model so that they can be done via USP.
Right. So the data models are well defined in TR-369. So again, when we are talking about data standardization models, Wi-Fi is many things, as you said. It is very complex. So data models might include RF metrics, or let's say client specific behavior, particularly roaming, right? It's very client specific, how the client decides to roam, or maybe we are talking about application specific behavior, how this specific application is behaving in this particular Wi-Fi network. So when there are many kinds of data that we get while we are dealing with Wi-Fi networks, what kind of data is being primarily sitting at the top that TR-369 is trying to standardize?
Um, So I don't want to say everything because it's in the power of doing it in TR-181 is that it allows you to connect the dots between other features of the networking device. So just really quick before I dive into the full answer to that question, the other thing that doing it this way, the other thing doing this way does is um, make things sort of technology agnostic. So for the mesh cases, even those that are relying on other backhaul technologies that are not Wi-Fi, that's made possible by doing it in TR-181, right? Which is extremely powerful, right? So like that's all done over 1905 and all that. Um, the the configuration, data elements itself from the Wi-Fi lines is mostly read-only stuff, right? It's mostly data and telemetry. Um, and then there are things that we worked with them back and forth between what was in the old model and the new model on configuration and other details. Uh, the the thing that needs to be the most standardized and has been the most standardized in the course of this project is data elements and the telemetry, right? Because that's the most important thing for for doing managed Wi-Fi, no matter how you're doing the intelligence on the other side, right? You're either doing it to do things automatically, you're doing it for support so that you can see if something's wrong, or you're doing it to manually change things so that they're, in the event that something's wrong and their experience gets better. But it's not that's behind all of it. And the magic of USP is that the old model in TR-69 and most other management protocols actually is that there's this one-to-one relationship between the device or one to many between the management server and the devices, right? What USP does is that using access control and roles, right, is it allows a multi-controller deployment. So different controllers can have access to different things and be responsible for different things. So one of the big things that is being made possible now is, and this goes all the way down into, the standardization of containers on the gateways through Purple Foundation and stuff like that, is the ability to drop a managed Wi-Fi application onto a device, have it only be responsible for the things it needs to be responsible for, and talk to a controller that is only responsible for doing a managed Wi-Fi piece, right? And be able to do it like that without 18 months of firmware upgrades. So that's really the dream right there. Is so we're now sort of disaggregating all the use cases so that like somebody who wants to build a managed Wi-Fi application can do that, and it makes it a little more agile too. Because if something gets updated or there's a new and better way of doing something, then it's not 2 years before you can deploy it.
Right. So, in today's AI context, so we see lots of AI models taking all over, right? So, uh, why data standardization and is important in this AI's world today, and how are we ensuring that cross vendors interoperability, particularly when we talk about AI related things and the data standardization models are happening?
No, this came up at NetworkX during one of the talks that we were doing on that Project Forum was hosting on the AI panel. This was kind of the main point: is that the the learning models won't work if everybody is giving it different things that mean different things, right? So it would never work with a host of different proprietary Wi-Fi mesh technologies. It won't, right? Because it'll get very confused. Yeah, it's literally language, right? And so it has to be that way. The data has to be standardized, right? And then the APIs being standardized too is just the way that we'll get to a point that these, the data that these things are being trained on can become larger and larger because it is all the same, right? Yeah.
Right. So, the standardization is taking place on API levels too. That's great to know.
Yeah. Well, no, I mean that's basically what the data modeling USP is, right? So it's like it's saying, yes, this is the way that you access that information, and this is what the information is going to look like when you get it, right? And like I was saying before, when it gets to the point where that is done intelligently, um, and automated, uh, with agentic AI, that's what you're going to be looking for, is that not just the data standardized, but the way that you talk to the device to make changes is, and then and then people can start building these things that have self-healing Wi-Fi, and that can be cloud managed or not cloud managed. Because the other magic of USB is because it's multi-controller, those things could exist on a smartphone, they could exist on the gateway themselves to control other things.
Right. It sounds very versatile to me. Now, what's the adoption of USB with vendors today look like? So, is USB already in deployments today, or is it still in early stages that vendors are yet to adopt the USB?
It is. So I think so Broadband Forum recently did a survey through Omdia. You can find that report on the broadband-forum.org actually. It's really enlightening. And one of the most promising things from my perspective anyway is that 88% of operators surveyed, and this was 115 operators from every region, like where there was a very diverse set. Yeah, yeah, 88% have either deployed USP or were planning to do so in the next 18 months. So that was very encouraging. And then the way that they're going about that, we've talked a lot at the Broadband Forum about it. There's some good materials on that, webinars and videos about making the transition from TR-69 to USB. And so you have some operators that are just using USB on new devices, and they're using it to do managed Wi-Fi, right? So it's like those big new use cases, that's what they're using it for. There's some that are doing like a hybrid model, so they actually have dual stack devices, right? And then there's some that are, flashing their legacy devices with new firmware that will run USB. So it's working. Mm. It was crazy. When I saw that, I was like, "Ah, phew, glad I didn't spend the last 10 years of my life doing nothing."
And yeah, so the adoption is there, but what about the challenges? So in deployments, when you are deploying TR-369, do you see vendor facing any particular challenges while going with the TR-369 model in field? So any issues or uh, any challenges that are being.
I'd say there's probably three biggest hurdles. The first is that there's always a chicken and egg problem when it comes to technology like this. And so vendors won't do things until the operators tell them to do it, right? But the operators won't do things until they see enough vendors doing it. So So it's like, make up your minds. Um, but we're over that hurdle at least. And another thing that's helping to address that is the open source community, right? Um, there's an open source stack of the USB agent, but that is also being used on RDKB and Purple OS. So as people are moving towards RDK and Purple, either direction, um, that'll be easier because it's going to be in there anyway. Um, the second hurdle is just the transition from TR-69 and understanding that transition, so that the people who are really locked in, especially on the OSS BSS side, right, of using TR-69 for stuff, that will take longer, but the transition mechanisms that we have in place are pretty useful for that, right? Because there's no reason you can't run both on a device. And like I said, some people are just doing it for new things, and that's great. The third one is ironically something that we thought would be a feature of USB, and that is it's almost like a layer 9 protocol. We we completely divorced it from the transport. So um, you know when we define a new message transport protocol uh, for USP to run over something else. Uh, we have, we define it and put it in the spec, but we didn't lock it down to one. So you can do, you can do it over WebSocket, you can do it over Stomp, you can do it over MQTT, and a lot of people have different opinions about which one is the best. So if I had to get the most common question I always get, it's like, well, which one should we use? I'm like, whatever one you want, man. Like, and But and consequently, because we divorced it so much from the message transport, we don't take advantage of some of the benefits of those transports, right? Which is one of the reasons we deprecated CoAP, because we weren't even using the things that are good about CoAP, right? It made it completely irrelevant. And then things like with PubSub like MQTT, we're not using the multicast features of that for security reasons and a number of reasons. So it's like, well, make your own choice based on that. But
Yeah, I think interesting set of problems. Transition being one, and even though you gave lots of flexibility, the you know people asking what to choose, that's also being one of the challenge. Interesting set of problems, I would say.
and I would say maybe the fourth challenge is one that is being overcome. And it was a challenge in the beginning. And that is like I was talking about in the beginning of the show about every technology going through the same phases and people fighting the standardization for a while. You've had that in the industry for a little while because the the big players in managed Wi-Fi, the ones that understand Wi-Fi well enough that they've written their own, that they have their own secret sauce when it comes to Wi-Fi mesh and optimization, um, all wanted to keep that advantage and standardizing that, you know. But when we talk about the inevitability of how every technology works out, we're at the stage where even those people are sort of like, okay, fine, we'll do it the standard way.
Yeah, I think that's a very interesting point, and I would like to extend the question on that particular point. So, given the diversity of vendors and operators, right, there are many of them, and when we talk about data standardization on AI models, are vendors and operators aligning and coming to terms and saying that yes, this is the model that we want to standardize? Are they coming to an agreement, or are there slight conflicts here and there about coming to that alignment?
They're coming to agreement on the data model. Everybody still does their own vendor extensions, unfortunately. But in large part, Wi-Fi Alliance and Broadband Forum are working together to make sure that those things like we said, that the data itself is standardized. The thing that there's two pushbacks, right? One is what I was talking about before, where you have companies who sort of built their entire business model on their secret sauce around Wi-Fi optimization, right? And I understand their pain, but this doesn't really go away. It doesn't really go away with standardized data models, right? Because all of the mathematics and all of the algorithms and the things that they've developed, that's theirs. They can do what they want. They're still going to get that as a differentiator. Um, the other pushback is privacy, right? So there is in two aspects. One is that data is very valuable, right? Especially from the operator's perspective. So how soon operators get on board together with sharing all that information so that the learning models can be that much better, I don't know. And then there's also the actual consumer privacy aspect, right? Where, especially in Europe, that is something that users have to opt into, like flat out, to be able to even share that information. Like I know, um, and this is public knowledge. Like you can watch this on some of the Broadband Forum's YouTube channels, but DT, they were deploying USP for this new managed Wi-Fi service, but they have to explicitly have people opt into it in order to offer it because that privacy thing is never one. So I think that will be a hurdle to getting, to getting large pools of data that are agnostic. Um, but we'll see where it goes. It doesn't necessarily have to be solved that way either. Everybody could have their own data pool. It's fine.
Right. Now let's talk about the standard itself again. So you said that TR-69 came around 20 years ago, a long time back, right? Now we have TR-369. So how has the standardization process changed over the years? So are we so I'm curious, right? Because how the process has been changed over time. Did we speed the standardization process, or what are the actions that we are taking? Because standardization can take a lot of time, and the sooner we have the standards, maybe the sooner the adoption we get. So I'd like to hear your take on that.
Yeah, no, that's awesome because this is something that I've been trying to hit home as often as I possibly can. Is that world is different now, totally different now. Standardization, at least from the broadband performance perspective, I know there's probably other groups that do things differently and they do things differently because they have to, right? Especially if it's more on the hardware level or in the PHY level. Um, but at the BBF, at least when it comes to USP and the data models, we treat it much, it is basically all software now, right? So we follow practices that make that very quick. So the data model itself is now being revved maybe every 6 to 9 months, right? Rather than 2 years. And we have a lot of tools in place to make sure that that goes a little bit faster. Um, but it's backed up by open source and by testing, right? And I always say that the three pillars of successful technologies, at least in communications, are standards, standards, open source, and testing. And if you have those three things, then it will be a successful technology. And we have those three things, right? And so having the open source community working so close with us, and then having open source versions of USP, and then making sure that we're doing the data model in an agile way, and then making sure there's testing and certification, right? I mean, that's what we end up doing at QA Cafe, right? Is testing all this stuff. Or actually, even TR-398 from you guys' perspective is a great example of that, right? It's like that was the missing piece. The operators were like, well, we need some performance metrics. And now that you have that, right? So you have the standardization of data elements, right? You have uh, you have the open source solutions like for Easy Mesh, like Purple Mesh and stuff like that, and then you have the testing and certification, and those things work together to make everything better and faster. It's always inevitable, but it does. You're right. There is an attitude in the past that standards takes a long time, and it's just not the way it works anymore, thankfully.
Absolutely. Loved your take. Uh, and good to know that the standards are evolving faster. We are not taking so much time as we used to do in the past. And now I'd like to see your future insight on how do you see managed Wi-Fi, USP, and AI-driven data models all coming together and driving the networks. How do you see the impact of future networks due to all three coming together?
I think the best answer to that question is the value to the operators, right? And ultimately to the consumers. Because what's happening is because it's because of the containerization thing, um, that entire service has been disaggregated such that it will be available to competition. And that's one thing we're definitely seeing, right? So at least, especially at Purple Foundation, you see a lot of application vendors coming in as members, right? And they're all building their own cool stuff because they want it to run on these gateways. And that competition is good because it's going to make everything better and cheaper. Um, and then the second answer to that question is the agentic AI thing, right? So the value of the, this is going to make the biggest difference when things are done automated, right? And that will happen by the standardization of the API and the data models. And once that all gets together, then you'll start seeing, um, and obviously we've seen this a little bit, but it's still proprietary. Is like you were saying, Wi-Fi networks that fix themselves when things are wrong, um, and that intelligence can live anywhere, right? It can live in the cloud. It can live in the gateway, right? Because these things are getting bigger and more powerful every day, and that's another one of the things that we saw in the Broadband Forum survey was a lot of people want to push the AI processing to the edge, or even into the gateway, so it can do that stuff right away. Um, and so when 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 the data is fully standardized and the APIs are fully standardized, and we finally start getting all this stuff together, the 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 big win will be when the automation is possible, for sure.
Yeah, cool to know that. Now, think of this as a rapid fire question, but you can elaborate on it if you would like to. So, do you really think that networks are going to not just self optimize themselves, but also self heal themselves in case of failure event? So, no human intervention, networks automatically fixing themselves, self healing. Do you think we are going to see it in the future?
Oh, yeah, absolutely. Absolutely. And some of that already happens, right? Like some of the basic protocols of the internet are already built to do that, right? Just the way the routing algorithms work when things go down. But you'll absolutely see more of that. I mean, that is probably the biggest thing that everybody's working on right now, right? At all layers. And again, just from the broadband forum perspective, that is the task right now of standardization. So not just in the consumer network and not just for Wi-Fi, but standardizing the data models and the APIs for all the rest, so it can happen, you know. And it's because it won't happen until that happens.
Yeah, good to know that. Yeah, so I think we are done with the questions. So if you would like to address our audience and share anything that you want, you can. And
uh, I guess I would say, um, I like that you asked the speed question at the end of standards, because standards they're also not boring. So one of the things that I always pride the thing that one of the things I find most important is making people understand that it is people like you and I that make this world work, right? And we're just a couple of guys, right? Like, uh, understand the understand the real people behind what's going on. Don't be afraid to get your feet wet, diving into standards, diving into open source, getting involved. Um, your opinions will matter, and at least at the BBF, we try to make that as fun as possible. And uh, yeah, it's don't. I I don't want to be an idealist, because I understand why things go certain ways when it comes to that process of standardization technology that I was talking about. But don't fight it. Don't fight it for too long, because it's going to happen anyway, and then you'll be on the back end. And that's happened to a couple companies very recently, um, where they kind of dug their heels in on their own stuff for too long, and then realized that that's not what they wanted. But other than that, like I said, I have my own show, and I like to try to get people on just to learn their little human piece of what it is that they're doing to help make the internet go. As I say at the end of that show every time, like, really, really own the nerdy stuff that you love doing, and have fun doing it.
right, great interacting with you, Jason. Jason Walls, everybody. Thank you so much for joining and sharing your valuable insights and spending time with us on this topic of USP managed networks and AI-driven data models. Thank you so much, and probably we'll meet you soon. Yeah, maybe we'll meet soon. Maybe another episode. We'll catch up.